Imagine that you're baking a very special cake for the first time. The recipe requires a careful combination of ingredients in just the right amounts, as well as the perfect conditions for baking. You follow the recipe meticulously, ensuring that you don't overlook any details. However, when you take the cake out of the oven, you notice it's not as fluffy as it should be. So, why did this happen? Perhaps you didn't realize that the room temperature was a few degrees higher than the optimal temperature for baking a cake. It's also possible that the ingredients you purchased from the local grocery store weren't of the best quality. Seemingly minor factors like these could have individually or collectively contributed to your cake not turning out as expected. This is an oversimplified example of chaos theory, a developing mathematical theory that explores the unpredictable behavior of deterministic systems. So, what is a deterministic system? In simple terms, it's a system where future states can be accurately predicted based on the system's initial conditions and current state. Chaos theory examines how small changes in the initial conditions of a system can lead to vastly different, unforeseen outcomes. This concept is epitomized by the butterfly effect, which suggests that something as trivial as a butterfly flapping its wings in one part of the world can trigger significant events on the other side of the planet. Our modern understanding of chaos theory began with the work of French mathematician and physicist Jules-Henri Poincaré. He was the first to discover the phenomenon he termed sensitivity to initial conditions. Poincaré proposed that, due to long-term unpredictability, determinism and randomness can become somewhat compatible. In a system, a small, often unnoticed cause can lead to significant effects that are impossible to ignore. When this occurs, we tend to attribute the outcome to chance. If we fully understood the laws of the universe, however, and how they came to be, we could predict outcomes with incredible accuracy. Unfortunately, even with complete knowledge of these laws, we could only predict the next state of the system, which is usually good enough. Based on that, we can conclude that the situation follows rules we understand. However, the reality is that small changes or errors at the very beginning, often overlooked, can lead to immense variations or errors later on, making perfect prediction impossible. This is when things start to appear random. These ideas laid the foundation for chaos theory. Chaos theory applies to many aspects of our lives, including mathematics, biology, economics, computer science, medical sciences, geology, finance, and politics, among many others. One of the most common applications of chaos theory that we encounter every day is weather forecasting. The atmosphere, with its currents and swirling clouds, is a prime example of a chaotic system. Despite the expertise of meteorologists and the use of advanced equipment and technology, even small changes in temperature or pressure can have a cascading effect, altering the final weather outcome dramatically. This is why weather forecasts can never be completely accurate. The stock market is another example of chaos theory in action. A simple statement or a tweet from a business leader can cause the stock market to plummet in a matter of hours or even minutes. Moreover, chaos theory provides insights into the spread of pandemics and their unforeseen consequences. For instance, millions of people became sick due to the coronavirus, which then prompted global lockdowns that profoundly impacted all aspects of human life. While we may not be able to predict every possible outcome of an event, chaos theory reminds us that increasing our knowledge and understanding of the world can help us navigate it more effectively.